increasing and decreasing function. A function can be determined whether it is increasing or decreasing with the sign of its derivative. Suppose a function is something 2x squared plus 1 like this. Okay, we have to determine in which interval it is increasing or decreasing. You just keep a rule in view that when f dash x is positive, function is increasing. When f dash x is negative, function is decreasing. Okay, for this particular function, if I have to check, I will find f dash x, which is coming out to be 4x. So this will be positive. 4x will be greater than equal to 0 when x is positive. That means for all positive numbers, this function is increasing, whereas for negative values of fx is less than 0, when x is less than equal to 0, the function is decreasing. So this, for this values of x, function is increasing, and for these values of x, function is decreasing. This is the most simple way how to check a function is increasing or decreasing. One more example I am taking. See, if fx is equal to sin x, you see. So to determine whether the function is, if I have to check in 0, pi, whether it is increasing or decreasing, I'll find its derivative, which is coming out to be cos x. We know that cos x is positive in first quadrant. That means in 0 to pi by 2, cos x is positive. That means in this interval, function is increasing. And we know that in second interval, cos is negative. So in the interval pi by 2, pi, it is decreasing. Okay, I am taking one more example to check the interval where it is increasing or decreasing. If fx is 3 by x plus 7, anything like this, we have to check whether it is increasing or decreasing, in which interval it is be having like that. So if I am finding f dash x, it is coming out to be minus 3 by x square plus 0. See, x square is always positive, so it is minus 3 into something positive, always positive, because the square of any number is always positive. So it is negative all the time. X belongs to R. For all values of R, x in R, it is negative except at 0, because at 0 it is not defined. So this function is universally decreasing for all values of x except x is equal to 0. One more example I am going to take to check the interval where it is positive or negative. It is fx is equal to x by x square plus 1. So firstly I have to find f dash x to determine the points of increasing or decreasing. So f dash x is coming out to be, it is in the form of u by v, v as it is, differentiation of u is 1 minus x as it is, differentiation of that is 2x by x square plus 1 whole square. So it is coming out to be, on solving, this is 1 minus x square by x square plus 1 whole square. Okay, so to check the functions interval where it is increasing or decreasing. If I am checking for increasing, you see 1 minus x square by x square plus 1 whole square should be greater than equal to 0. This can be neglected. Why? Because square of a number is positive and positive thing can be neglected. So actually it is 1 plus x into 1 minus x. Okay. This can be further written as x minus 1, x plus 1 less than equal to 0. So we will see where it is positive or negative. The critical point is minus 1 and 1. You just write it here. First interval positive, second negative, third positive, like this. It is minus infinity, this is plus infinity. So if I have to check where this thing is negative. This thing is negative in this interval. That is minus 1 to 1. Minus to 1 to 1, this expression is negative. That means that f dash x is positive. So in this interval it is increasing. So increasing in when x is between minus 1 and 1. And same way we can find this function to be decreasing here and here. So easily we can find the points in the interval where the function is increasing or decreasing. You just proceed in this way. You can solve the problems of increasing decreasing functions very easily.